the coral reef ecosystem undergoes regular minor disturbances, which wipe out a lot of the abundance and diversity of corals, but they're able to come back from that. They're able to come back from that in two ways. Here, we've kind of modified this. This is an area that died from bleaching. All these corals are dead, but then we were able to transplant some corals from our nursery onto here. So these will grow out over this area. That's not necessarily the natural way. The natural way that reef recovers is in two ways. So corals have two reproductive cycles. And the first we're going to discuss is the asexual reproductive cycle here. Now, the asexual reproductive cycle is the process through which coral polyps reproduce themselves. Each coral polyp in the colony is a clone, remember, so they all have the same genetic material. This one's the same as that one, and so on. So these will continue to clone themselves and reproduce through asexual reproduction. Now, this can help the coral in many ways. This is how the coral grows larger. It's how it expands in its surface area. It's how it recovers from minor mortality. Like if a butterfly fish came and ate a couple polyps, then this is how they would replace themselves. Or if there was sedimentation or some other event like that. For some corals, it's also how they spread out, mostly like the branching or the dense corals like Poecilipora that are prone to breakage. Sometimes the branches break off, they fall onto a non-sandy area, and they're able to grow again. And so sometimes we see a big area full of branching corals, and that can actually be monospecific, or all the same colony that has, broken apart into daughter colonies. So this asexual reproductive cycle is nice because it's metabolically cheap. It doesn't take a partner. You can do it anytime. So this is what they use to, increase the colony size, repair damage throughout the year, and to increase in size and occasionally to fragment into daughter colonies for some species. But this is the way the coral can come back from very minor disturbances like fish predation or sedimentation or other events which don't kill the entire colony of corals. Now, the other reproductive cycle is the sexual reproductive cycle. So this is not going on all the time in corals, but instead goes on once per year. So this is the development of gametes, the sperm and eggs, or the sex cells for the coral, the release of those into the water, the fertilization with another adult or colony that becomes a partner. And then the larvae will develop in the water column, spread around, and settle down and create new coral colonies. Coral colonies that, unlike the asexual method, have new genetic material. So they're not clones of the original colony, but they are, like when we reproduce or any other animal, they're genetically unique. Unique to deal with the different stresses and changes in the environment, possibly. It's also how corals get to new areas. They're in the water column for 4 to 7 days. If it's a very large bay, that might mean that they stay in that bay. If it's an area with currents, they could travel, tens to hundreds of kilometers before settling down. So the corals that reproduce might not actually be reproducing and seeding their own reef, but they might be seeding a reef that's way downstream or around a coastline. When we have a reef that dies, like in that first photograph that I showed you, where we had that big Acropora area that there's nothing living there, how does that come back? That's not coming back to the asexual reproductive cycle. There are no corals in that area to continue to create new polyps and clone themselves or fragment and refill that area with corals. So what we have to have there, and in other highly disturbed reefs, is the sexual reproductive cycle being successful. And there's a lot of criteria for that to be successful. For example, we have to have a high abundance of adults. If we have just one big coral in the bay and that big coral releases the eggs and sperm, it can't self-fertilize. So that's going to be a completely unproductive event. There will be no offspring created in that event because corals cannot self. Or we could have several big, large corals in that bay, in that reef, but they're too far apart. So when they release their gametes, the gametes don't interact together. We also need to have high reproductive success. So when those gametes are released, they need to be able to fertilize. They all rise up to the surface, as we'll discuss later. If we had, say, a rainstorm and all those larvae floated up to the surface and were suddenly in a freshwater environment, like a freshwater lens on top of the salt water, then they would all perish if the waters were too hot or too polluted. There's other reasons why we can have low reproductive success. And we need a high larval survival. So they need to be able to develop in the water column, find a reef, settle down, grow. All these things need to happen. Those three requirements, and each one's quite complicated and in depth, we can have a whole lecture on any one of those things, need to occur in order to get recovery of the ecosystem, in order to get those new larvae that seed the reef. If we don't have any of those, or any one of them is not going to happen, then we won't end up with recovery of that ecosystem. We'll end up with that phase shift to an algal reef ecosystem like we saw in those USGS photographs from the Caribbean. So there's a lot of requirements to reproductive success, sexual reproductive success. And like I said, there's a whole list of reasons why we might not get reproduction. And if you think about it, corals are living for, some corals are on this planet tens of thousands of years. Others, more like hundreds of years. So if they're reproducing every year, it's not necessary that they have, in normal conditions, that they have reproductive success every year. As long as eventually they do. So we can see tons of reasons why they might not have success, because there's too little of them, they're too far apart, they're too stressed out, the environmental conditions aren't good, there's no upstream reef, or the downstream reef it has issues. We have to think about connectivity, lack of available substrate. If all these coral polyps end up in an area that's full of macroalgae, then they're not going to make it. And then the symbiotic organisms. So there's tons of reasons why a reef might experience reproductive failures. So let's talk about how these reefs are being managed then, because we are seeing this more and more around the planet. A lot of people, of course, are taking actions to fix it. Unfortunately, when we look back in history, people have been seeing these issues, like we talked about coral disease and bleaching and nutrient loading, have been going on since the 1970s. And there's a lot of papers since the 1970s describing these dangers and these threats to reef health. However, there seemed to be a big lag between identifying the problem and actually doing something about it, to actually implement protections or to implement restoration, and to try to stop these issues or to bring back the ecosystem after it's been disturbed. And when there has been action, it's been primarily based on the idea that we can just stop making problems and the area will come back on its own. So this comes primarily from terrestrial ecosystem. So we look at something like a jungle. If somebody goes in and cuts down the jungle and we just stop them from cutting it down, that jungle grows back quite quickly. If you ever lived in a tropical area, you know that you're always fighting against the jungle coming back. But the coral reef is not like that. And so we can't necessarily go into it with that same way of thinking. So for many years, about 4 decades, the main way of protecting reefs was through marine protected areas, or MPAs. And this is basically, fundamentally the idea that we go in and we close this area off to human use, to commercial use, and to the economics. And this has had very limited success, unfortunately, primarily because, like we talked about, reefs are connected. So if you see that a reef is not doing well and you close it off to use, it doesn't necessarily mean that the larvae are going to be coming in, because have you looked at where the larvae are actually coming from, those upstream reefs that are actually the sources of the larvae? If you're not protecting those, then your MPA is not going to be very effective. The other issue, there's a lot of debate about MPAs because it does, oftentimes exclude the local communities, many of which are tribal or have been there for, generations or thousands of years, from actually utilizing those areas when the benefits to the ecosystem are not that well proven. And so these for decades, it was basically we prefer protection over restoration. And while I do agree with that, I would add that most of the time we don't really have that luxury. It would be wonderful if we could just protect all these reefs, but we're talking about global threats of climate change. We're talking about ocean acidification and coral bleaching. You can't really put a rope around an area and protect it from those things. You can't just stop fishing and expect that the reef's going to come back on its own. So while we do need these passive measures, while they are a wonderful first step and they should definitely be implemented, they're not the silver bullet. They're not the only thing we should rely on. Once we start to protect these areas, then we actually need to go in and put our time and money into helping to bring them back. So what we found after all these decades of going around and implementing MPAs, today about 32% of the reefs around the world are protected. And yet the reef decline has risen from 1% per year before 1997 to over 2% per year. And I should update these numbers, but we haven't had very good estimates lately. But this rate has probably even increased. So what we can say is that we do need MPAs, but they're not working. And what I mean by that is, like, if you have cancer, yes, you need to have a good diet, but you also need to treat your cancer. And that's kind of like what this is doing with it. We should think about when we're talking about restoration. Other things, ecosystem fragmentation. As we get fewer of these ecosystems, there's less of the larval supplies. And so we get, less effective MPAs. And so we actually do need to go in and start doing active things to bring these areas back and to help them out.